Greetings, I'm Mike Grontman. This video clip describes properties of the satellite constellation for the Global Positioning System, GPS. More video clips illustrating other effects of interest to space mission design and to spacecraft design can be found at the website astronauticsnow.com. The simulations are performed using AGI's STK. This video clip describes properties of the satellite constellation for the Global Positioning System, GPS. The red vector facing you is the vernal equinox vector. The yellow band on the surface is the equator. The Global Positioning System provides three-dimensional position and time information worldwide 24 hours per day for users equipped with GPS receivers. GPS satellites transmit navigational signals. The concept is based on measuring time intervals for signals to reach the observer. The user must receive simultaneous signals from at least 4 GPS satellites. In other words, 4 GPS satellites must be directly seen by the user, constrained by the minimal elevation angle. The elevation angle is the angle of satellite over the horizon as seen from an observation point. We illustrate the visibility of satellites for a GPS user in Los Angeles, California. Red lines show when the satellites are in direct view. In this our example, we require the minimal elevation angle of satellites to be higher than 25 degrees. The GPS constellation consists of at least 24 satellites. All satellites are in orbit with a period of 1/2 of one sidereal day, roughly 12 hours. Orbits are circular with a radius 26,562 kilometers and inclination 55 degrees. The GPS satellites are deployed in 6 orbit planes with the points of crossing of the equator distributed in longitude. In other words, the orbits have different right ascensions of ascending nodes. The GPS ground control segment maintains the points of equator crossing within 2 degrees from the nominal values. The minimal GPS constellation includes 4 satellites in each GPS orbit plane, with total 24 satellites in the constellation. Adding more satellites to the constellation increases the reliability and robustness of the system. Today, in 2007, there are 30 operational satellites. Our simulations show 29 satellites. You can see that the user on the ground always receives signals from at least 4 GPS satellites simultaneously. A view from a user at Los Angeles offers a different perspective on accessibility to signals from GPS satellites. One can see the stars moving in the sky as the Earth rotates about its axis. Solar illumination also changes during the day. The red lines again show the directions to satellites in direct view. These lines show a complex varying geometry of satellites available for determining users' position and time. This satellite visibility pattern is typical for the GPS constellation. Sometimes 5 or 6 or even more satellites are in view for a user in Los Angeles. Note that with the increase of the minimal elevation angle, the satellite visibility or the number of satellites in direct view would decrease. More video clips illustrating other effects of interest to space mission design and to spacecraft design can be found at the website astronauticsnow.com. Thank you for watching. I am Mike Grontman.